Okay, so hello, my name is Ahmed. I am a sophomore studying electrical engineering and computer science, and today I'm going to be talking about TensorFlow and Raspberry Pi. Uh, yeah, okay, why is this not working? Okay, there it is. Okay, so there should have been pictures there. I'm not sure what happened to them, but like I said, I'm a sophomore at Rutgers studying electrical engineering at the Honors Academy. I'm planning a double major in electrical engineering and computer science. I love robotics. I've been doing it since like the seventh grade, and I've really had a hard time, like not living without it, especially during the pandemic. Very tough time. Um, Outside of robotics, I'm also a decent basketball player, average, I can play. I'm in LA for Gen Chem for the Gen Chem class we had, and I know it was rough for some people, but it is what it is. I like to just mess around with things like tinker and create. I coordinate youth group activities at my local mosque. I'm a very outgoing person, but I'm very bad at remembering names, so just keep that in mind. Like I will not remember anyone's name unless I've known them for like at least a year or two. So let's keep that in
Luckily, our
mind.
names are on the side of the screen.
Yeah, that's what I love that about Zoom meetings. It's like I don't have to like remember people's names. No, it's just all there. Okay, so really quick, just to like it's a quote of it. It's a quote. It's not the actual like what TensorFlow is, but it's just like it's basically TensorFlow. You can read it, but it's basically an open source platform for machine learning and allows you to do a variety of things that would be normally a lot more difficult and a lot more time intensive if you're trying to implement it on your own. So TensorFlow is kind of just like a platform that allows you to combine everything and do it a lot easier. So yeah, so more about TensorFlow. TensorFlow is essentially a collection of programs and packages that allow for individuals to utilize their hardware and software for machine learning applications. It was developed by the Google Brains team and first released to the public in 2017. Main uses of TensorFlow include classification, perception, understanding, discovery, prediction, and creation. Another thing that's not on here that I'm not sure why, but it's also used for developing models for other programs. So like other machine learning programs use TensorFlow to develop their models. I'll get into a little bit more what a model is later on. Okay, so there's basically three different versions of TensorFlow. The first one's TensorFlow, the main version of TensorFlow. It uses Python on most hardware, and it's the most commonly used by far. It has a load of functionality such as complex input lines, internal model creation, acceleration, and hardware acceleration, and it includes Keras. It's a very high-level API that allows for the creation of very complex machine learning models, which I wish we could do on the Raspberry Pi, but unfortunately, it's not there yet. I'll get to that in a second. TensorFlow JavaScript is basically just TensorFlow, but for JavaScript. It can create new models, right? Machine learning models, but also it can also run existing models on JavaScript. And finally, TensorFlow Lite. This is what we're going to be using for the Raspberry Pi. It's designed for Internet of Things devices and mobile. It's optimized for on-device machine learning for devices such as iOS, Android, Raspberry Pi, embedded Linux, and microcontroller. As I mentioned earlier, this is what we're going to be using to work with the Raspberry Pi. And unfortunately, one of the one of the most disappointing things I discovered when I was first starting to use this is that the machine learning creation, or the model making on TensorFlow Lite is not like very good yet. There's like an experimental version, but that experimental version doesn't work very well without some tweaking. So just keep that in mind. Okay, so what exactly is machine learning? This is just like, I think it's a 2-minute clip from one of the people at Google that just describes what machine learning is. Let me know if you can hear the audio.
Thankfully, it's not hard to take advantage of machine learning today. The tooling has gotten quite good. All you need is data, developers, and a willingness to take the plunge. For our purposes, I've shortened the definition of machine learning down to just, thankfully, it's not hard to take advantage of machine learning today. The tooling has gotten quite good. All you need is, thankfully, it's not hard to take advantage of machine learning today. The tooling has gotten quite good. All you need is data, developers, and a willingness to take the plunge. For our purposes, I've shortened the definition of machine learning down to just 5 words. Using data to answer questions. While I wouldn't use such a short answer for an essay prompt on an exam, it serves a useful purpose for us here. In particular, we can split the definition into two parts, using data and answer questions. These two pieces broadly outline the two sides of machine learning, both of them equally important. Using data is what we refer to as training, while answering questions is referred to as making predictions or inference. Now, let's drill into those two sides briefly for a little bit. Training refers to using our data to inform the creation and fine-tuning of a predictive model. This predictive model can then be used to serve up predictions on previously unseen data and answer those questions. As more data is gathered, the model can be improved over time and new predictive models deployed. As you may have noticed, the key component of this entire process is data. Everything hinges on data. Data is the key to unlocking machine learning, just as much as machine learning is the key to unlocking that hidden insight in data. This was just a high-level overview of machine learning, why it's useful, and some of its applications. Machine learning is a broad field, spanning an entire family of techniques for inferring answers from data. So in future episodes, we'll aim to give you a better sense of what approaches.
Okay. So yeah, that's basically a high-level overview of what machine learning is. Just a heads up, just for me, how many of you have experience with machine learning, just in general? Because I'm actually kind of curious. Like, do you guys have experience with it or no?
I know a little, but I've never worked with it.
Okay. Interesting. Okay. Okay, so first off, just why machine learning, right? Or why specifically for me, I wanted to get into machine learning. So over the last summer, I was traveling, right? I was traveling to go see family in Egypt I was basically gone for the entire summer. And so I wasn't really able to go to any kind of internships or and do any kind of big projects here. So I decided to give myself a major project that I can do over the summer, something that I could bring with me to different places, something that I could carry around. And I came up with this. It's basically a robot that I came up with that I when you're typically designing a robot, you're designing for, you're trying to achieve a certain goal, right? Or you're trying to have the robot do a certain thing. For me, when I decided to make this robot, I kind of did the opposite, where I basically designed the robot about what I wanted to learn about, right? So that was one of the big things that I just really wanted to learn a lot of different things. So I designed the robot around what I wanted to learn. So the final objectives of the robot, right? So obviously, like I said, the objectives were based on what I wanted to learn, right? And so the final objectives I came up with were driver control through remote control, right? So you just have a remote control and you'd be able to drive it. And the ability for the driver to see surroundings, right? And then the ability for a robot to take control and follow people, right? So let's say you're driving forward and all of a sudden, whoop, you see a person, right? So now you want the robot to suddenly follow that person. So that's something those are the three main goals I had for this robot. Some of them I've reached, some of them I'm still working on, and I'm just going through the second iteration. But really, in this case, if I want to follow people around, right? If I wanted to recognize, if I wanted this robot to follow people around, I need to determine what I need to somehow figure out what a person is, right? And that's where I use machine learning. And also other things, right? If I want to implement more into the future, such as do this or follow a cup or do something, right? So do something based on what's in front of you or what's around you, machine learning is the answer. So once again, yeah, so basically what I talked about, why machine learning, right? In order to actually determine whether the robot was looking at a human or not, machine learning was needed. Using machine learning on a live feed also enabled the development of capabilities such as tracking, right? And in combined, this is something that I didn't really get to do yet, but I'm definitely planning on doing for the V2 of this, was combining with other sensors such as the sonar sensors and range sensors and the touch sensors to increase the capabilities of following objects or tracking distance or doing whatever I want to do with it in the future. Right? And so now I'm going to get into the what's it called? Basically, like how to implement this. It's not hard to implement. There's really not much to it. So just a heads up, I made these slides before anticipating that I wouldn't be able to share my screen. However, lo and behold, I was able to figure that out like 30 minutes before this meeting. So now I can actually share my screen, and I'll go through the full process later, and I'll show you guys what's actually going on. But right now, this is just like the process of setting up. So you're configuring your Raspberry Pi, right? And you want to turn on your camera. So you're gonna go interface options, you're gonna turn on your camera, yada, yada. This is all stuff. Actually, you know what? Let's go through this on the Pi, because I feel like it's a little bit more easier to see if I do this on the Pi. So let me X out of this. Continue on the Pi. Okay, so it should be connected. Oh wait, that's the wrong thing. Okay. So the first step, right, is you're gonna want to turn on your camera, right? So you're just gonna do sudo RaspBerry basically.
Can we make that bigger?
Can I can. I think. Can you see that? I can make the window. I don't know if I can necessarily zoom in.
Like Command plus, does that make the text bigger?
Oh, edit. I didn't think about that. Oh, here it is. Zoom in. Okay, again. Is that better?
Thanks.
I can make it bigger if you need to. Edit.
Maybe just like a little bit bigger.
Okay, so yeah, so this is just going to open up the configuration menu, and the first thing you're going to want to do. Oh wait, I didn't even talk about the camera. So yeah, you're going to want to enable the camera, right? That's the first thing. I'll talk about a little bit more about the camera in a second, but you're just going to want to go into. Oh, wrong one. It is connections to peripherals, interface options, and you're just going to want to make sure that your camera is enabled, right? Camera interface is enabled, finish, right? That's the first step. Okay, so the next thing, according to our slides, my slides rather. This thing is really annoying. Okay, so the next thing is we are going to want to, we already did that. So basically this next step, all these commands are basically enabling, or basically allow you to download the library, right? So this is allowing you to download the not just the library, but it's also the environment itself, right? So the TensorFlow library and some of the basic examples that come with the TensorFlow library. I'm not going to repeat the download just because I don't want it to mess up what I already have set up, but you can just, I'm sure we can share these slides after, and you can take a look at this code. And yeah, so after you install it and it gets all set up, it's going to look something like this. Obviously, I'm going to go into a little bit more of what the code looks like, but this is essentially what it looks like. Also, this is using a very bad camera before, so it's very blurry, and you can probably tell. But this is like other implementations I've seen on like phones, because this doesn't only apply to Raspberry Pi, right? You can do this with phones and other kinds of things. So this is basically what the output might look like. So now I can actually show you. Let's go. Unfortunately, like I said, I was having issues earlier with this, but I will be able to share what I am seeing through the camera. So if I go to Zoom, oh God, stop share for a second. No. Sorry, this is a little unorganized. Yeah, so basically, this is on the GitHub, right? I have the link in the slides, but basically if I run the following, oh wait, I'm not sharing anything. What am I doing? Yeah, unfortunately the iPad had to come back. Basically, if I run the command that where'd it go? Right, this, you'll see that I have this camera right here, right? By the way, this is the camera I'm looking at, right? This is much better than the one I had before, but it's basically connected to the Raspberry Pi through the little interface in there, right? So you just plug it in through the interface and you have the camera on the outside. And after you enable it like you did, you can already see that there's kind of some boxes around, right? There's kind of some boxes around. So if I go, oh wait, I forgot that is the camera that is recording. I cannot hide that. So yeah, so if I look at the camera, right, and I look at the screen, let's say I put like a cup here, right? You can see that the screen is trying to, oh my gosh. You can see that the screen is trying to, like, it's registering that there's a cup there, right? And it's telling you basically that number below it is how much, like how confident it is in that is actually a cup, right? So that's just showing you the confidence level that is a cup. It's also picking up some other things as well, but that's just basically for that. And that's pretty much it, honestly. But there's a few other things I can just do like a good high level overview of the code. So yeah, you can understand it and modify it. Stop sharing. Okay, so back to the code. Okay, so where'd it go? So back to the code. Right. So this is.
So it printed out the labels of the things that it found?
Yeah, I'm gonna get to that in a second. Yeah. So basically, right, you have, it's importing a bunch of libraries that it's using, right? We're just setting this is just setting the height and what's called the dimensions of the image itself that's printed out, right? And so one of the key things that you'll need to look at, right, for your code is, where is it? This, right? You'll notice that in my output, right, I have it printing a few things. So I'm checking to see, I'm just declaring like the average threshold, right? So if I was to look at, let's say, the cup on the camera, right? If it was on the left side of the camera and outside of that threshold, right, I would say it's on the right. So you can see, I actually never moved the cup on the left, right? But if you look at, I also have an else if statement saying if it's on the left, I'm printing out that the cup is on the left. And so, right, there's using just the position of the bounding box, right? The bounding box was the red box that was surrounding the object, right? I could determine the min and the max, right? I could like subtract the min and the max from each other to determine where the center is. And is the center approximately on the left, on the right, or in the middle? And then I just display that output through there. I also had it set so that anything it detected, right, it could print. And obviously, it's not the most accurate thing in the world, like parking meter. I don't have, as far as I know, I don't have a parking meter in my room. But like, it's fairly accurate. And obviously, depending on like lighting and all that stuff, that definitely impacts. There's a lot of parking meters. What the heck? But just based on like lighting and like stuff in the environment, it's obviously going to impact the accuracy of what's going on in the camera. And then the other thing to consider is the threshold, right? So if I were to, where's it? It's before. Yeah, okay, so basically this other value that we're looking at is the threshold right here. So let's say I want to be really accurate about what I display on the camera, right? Because you'll notice that when I was displaying it earlier, there were a lot of different, what's it called? There are a lot of different boxes, right? And some of the boxes had like low percentages where it's like 0.4 and 0.45, right? It's not very accurate. You can change this, right, to be another value such as 0.7, right? And so now, unless it's 70% confident in its answer, it's not going to show up. It's not going to show the bounding box. So yeah, and then the other thing that is, where is it? The other thing that's pretty cool, right, is you can take these inputs, right? So the Raspberry Pi, it's more than just a little computer with a camera, right? There's all these, I wish I had a picture of it. Actually, let me go back to the slides for a second. There's all these little, oh, I don't have a picture of a Raspberry Pi on it. Do I? No, I don't. Okay, it's fine. So the Raspberry Pi has all these little pins on it, right? And so what you can do with these pins is you can plug in, let's say, a motor, right? Or an LED or a switch, not switch, and the motor, an LED or something, right? Even a switch if you want to. And you can control, right, physical objects, right? So instead of me printing right, right, instead of me printing that we're going right, I can say, oh, move this, set this pin to high to turn on an LED, right? Or run a motor this amount, this certain speed, right? So there's a lot of possibility with a lot of possibility with what you can do with this. But the main things you're looking at, right? The main things you're looking for if you're trying to do an action based on like the objects or the position is this object class ID, right? So that's going to tell you what's it called? That's going to tell you what the object is. And you can also like redefine an object. So let's say I go into what I can do actually is I can go back. Where did I save it? I can go back and see, right? So, oh yeah, just a heads up. So this is talking about where it's looking for the model, right? It's looking for the model that comes pre-installed with the environment and also the labels for that model. So let's say if I go into, where is it? So it's /home/pi, right? So if I go into here and I open Cocoa labels, where is it, right? I can change, right? If I find cup, I can change it to, let's say, I don't know, potato, right? Hypothetically, right? And I could save it. And if I rerun my code, right, I won't be able to show the display. But if I rerun my code, right, you can, see the display is labeled over this, but not actually visible, right? And now it's telling me, hey, it's a potato, right? So you can redefine, right? If you're using other models, right, or you're using your own model, you can define what the name of the object is, right? And the characteristics are based on the model maker, right? The TF light file that was over here. Let me stop this. Okay, right. So the characteristics are all in the TF light file, right? And I can't open that on the Raspberry Pi itself, right? But when you're making a model, right, not on the Raspberry Pi, you can make the model on, let's say, a computer using Tensorflow, right? And then upload that to your Raspberry Pi, right? And then use that model with the labels to define what the objects are based on the certain characteristics that they have, right? Okay. What else is there? I think that's all I have in terms of like actual physical things. Like I said, there's a lot more you can do with this, right? This is just one example. But I want to talk a little bit more about methods of improving accuracy, right? Because that's a big thing that I struggled with earlier on. So obviously the one thing that I said was increasing the minimum threshold for accuracy, right? So when other objects are still, the other objects, right, they're still being computed, right? Their bounding boxes are being made, but they're just not being displayed, right? And so if you set that threshold, right, at that 0.4, oh, nope, that's not what I want, right? So you have your 0.4, you have whatever threshold you want, right? You can determine, that'll allow your robot to only make more, or output, right, more accurate predictions, right? The other computations are still being done, they're just not being outputted. The other thing you can do, right, there are other methods include higher quality in picture, right, or video, is you could see from before, I don't know if you guys could tell based on what was happening, live, but that camera, the one that's over here, is a lot worse than the one I'm using now, right? So, and using a higher quality camera can result in a lot more accuracy, right? Adjusted lighting in the environment, it prevents reflections and bright light from distracting the program. You can also make machine learning model adjustments. Unfortunately, it's not, you can't do it directly on the Raspberry Pi, right? But if you're to use just TensorFlow on a computer or a PC or something like that, you can certainly adjust it, right? And you can also train it, right? The other thing that I totally didn't talk about is training, right? So basically you're providing some files, right, or some pictures or whatever, and you're saying, hey, these files are flowers, right, or these pictures are flowers, and you're telling the computer that these are flowers. And so the computer, depending on the algorithm, right? In this case, TensorFlow has its own algorithm, but it'll basically go through and determine what characteristics, right? Or what, yeah, so basically what characteristics make this a flower, right? And so by training a model, right, and making your own model, you can certainly adjust the accuracy depending on your application. The model that comes with TensorFlow is a general application, right? It's nothing specific. It's just a general it's just a big example of a lot of different things that TensorFlow or that it can pick up, right? However, the other thing that is important, right, if you're going to train a model in the future, is that too many images with high amounts of variation, especially during comparison, can result in inaccurate data and larger pre-processing time. So I know it's something that probably won't get to anytime soon, but basically if you have too many pictures with not enough, and there's like, you're saying that, let's say hypothetically, it wouldn't be this far apart, but let's say you have like a petunia and a daffodil, and you're calling them both a daffodil, right? The computer is going to get pretty confused in terms of what it actually, right? What a petunia or what a daffodil actually is, right? So it's going to have a harder time distinguishing between the two. So having clear images that are actually what you're looking for, right, will help speed up the processing time and also just make it a better mental model. So other cool things, right, you can do with your TensorFlow and Raspberry Pi. That first one, the training your own model by using Cadus to upload pictures, you can't do on the Raspberry Pi, but you can do on your computer and then transfer it to the Raspberry Pi, right, the file itself. That one I haven't tried out myself. I was trying to do it until I discovered the whole can't do it on Raspberry Pi thing. Kind of sucks, but it is what it is. You can add behaviors that occur after detecting a certain object, right? That's something that I did that I was using for my program, right? On the robot, it would turn left if it saw a human and turn right, depending on where it was, right? And so you could also like sending notifications to phones, flashing light, etc. TensorFlow isn't only as well, what's it called? TensorFlow Lite isn't just for pictures, right? I've been talking about pictures this whole time. There's a lot of other things it can do. It can convert text images into words, right? That's still, what's it called? That's still that's still, what's it called? Machine learning, right? But it's using, if you've ever heard of OCR, optical character recognition, that's basically what that is, right? And so there's a lot more applications than just pictures. So you can also use machine learning to determine sound or what is making that sound. I actually didn't know that existed when I first started looking into this, but apparently you can play a sound into like a microphone, and TensorFlow will try to figure out which sound or what is making that sound, rather, based on the pre-programmed, what's it called? The model that it's using. So facial recognition, right? So facial recognition of different people, and obviously there's a whole privacy issue, right? But the thing to remember with TensorFlow is that's a closed loop, meaning it's all offline and nothing is connected to any sort of database or internet, right? So everything I showed you today, right, I'm not storing it or anything, but if you were to store it, it would be stored locally on your computer. It wouldn't be shared with anyone else, right? And so the possibilities are limitless with TensorFlow. And the final thing, right, these are the resources, but I actually wanted to just open up, where is this one? Yeah. Yeah, so this link is actually, there's like, if you look on the TensorFlow website, there's a lot of different resources, right? So there's a lot of different resources on the Raspberry Pi, right? So not even Raspberry Pi, just TensorFlow in general. This is the library that I used in particular to set up my thing, right? And it even gives you step-by-step instructions. So everything that all the code that I showed you, it's all on here. Oh wait, no, that's not the same one. Object captions. Yeah, so the TensorFlow website is filled with a lot of different tutorials you can follow and a lot of different things you can look at. And I would definitely recommend, if you have a Raspberry Pi, right? I would definitely recommend trying it out with a camera, right? It's just a lot And it's a really good basis for getting into machine learning. And yeah, that's pretty much all I have. I'm sorry for being very unorganized, but I hope you enjoyed it, and feel free to ask me any questions. Like I said, I'm still decently new at this, right? I've only started this 6 months ago, but yeah, if you have any questions, feel free to let me know.
I have a series of maybe seriously dumb questions, but let's answer Rich's question first
Go ahead.
because I feel like that's part of my question. He says, what type of CNN model are you using?
I'm using the basic model that comes with the TensorFlow. Like I said, I'm not really haven't gone that much depth into model or into like developing the models themselves. I'm just using the generic one that comes with TensorFlow.
Cool. Okay, so I guess the kind of answers one of my questions, which was like, what model were you using? But I guess you were just so someone made a model to detect some objects, put it up on this website, and you downloaded the weights and put it onto the Raspberry Pi.
Right.
How do you do that? Like, does the Raspberry Pi, like I know nothing about the Raspberry Pi, does it have its own like screen or like
Okay, so
I don't
yeah, okay. I didn't think about that. So real quick, Raspberry Pi. So Raspberry Pi is basically like a little computer, right? So like I use what you're seeing right now. This is my Raspberry Pi, right? So it's basically a mini computer, right? So it has everything from browser to file explorer, right? It's basically running on a version of Linux, right? It's not Linux, but it's a version of Linux, right? And so you can basically do whatever you could do on a computer to some extent, you can do it on a Raspberry Pi. And so all I did is I just downloaded the environment that came from TensorFlow, right?
Cool.
The library, and then I just followed most of this was honestly what was on the website. The little piece that I added for this was well, for this presentation in particular was just the printing out the labels and then also the calculations for turning left, right, and center, right? There are also things that I did where it's like I turn on a switch or I'd run a few motors sending a serial signal. But like I said, there's a lot of openness to this, right? This is just the bare bones beginning. I would have shown you the robot itself, but after coming back from Egypt, it doesn't work anymore. And I have not had the time to fix it yet. But yeah, that's pretty much it.
And then Rich asked again, is the model customizable? So like do they give you the Python script that has the model definition in it, or is it really just like the weights file? And then they
So
load it and use it? Or like where's the code where they like take in the images
okay,
and process them, I guess?
so there is, like I said, you can't do this on the Raspberry Pi, but I believe if you go into TensorFlow, just a quick overview, you see tutorials. Because I was reading about this because I was trying to implement it on here, but where is it? ML Basic. Maybe it's this one. No, this is not it. Model understanding, reinforcement learning. Yeah, so is it this one?
Maybe save and load.
Save and load.
That's probably where they're like taking the weights in and
Yeah,
with the models.
yeah. So yeah, like I said, I'm not a complete expert. I really don't know much about the models themselves and developing them. I'm just going like based off what I understand. But I would definitely recommend if you're interested in that kind of thing, looking at the website because they're probably help you a lot more than I can. Right? The whole reason I want to do this was to let people know that hey, this existed. So
Great. Thanks.
yeah. Yeah. Sorry I can't be as much as a help as I should be, but I hope that answered all your questions.
It's totally cool. Okay. Does anyone else have any questions?
I've got a quick one, a little unrelated or related to the last part of your talk, where you discussed how the machine can also identify the sorts of sounds.
Yeah.
First of all, that's really cool. How close, or I guess which are machines usually better at? Is it better to identify objects based on visual data, or is it more accurate with sound data? Or I guess the more leading question is it easier to fool a computer based on sound compared to with visuals?
Like I said, you're asking the wrong guy. I literally just looking through the features. I think I was scrolling through here and I was like, hey, you could figure out sound. That was pretty cool. But I have not looked into the sound thing. I have no idea how the sound one works. I'm just telling you that it's something that's doable, right? And they have like a tutorial on it. I forget, but yeah, sorry about that. I really don't know
No,
anything
no,
about
no.
the
It's,
sound.
it's fine. That's just really cool. I'd never heard about that
Yeah,
before.
neither
So
have I. That's why I put it in there. I'm like, wait, what? That exists? Because yeah, I'd imagine it would be like you could definitely like mess it up with not mess it up, you know what I mean? Like try to imitate certain sounds with just like computer or like disrupt the audio. So yeah, I could imagine it'd definitely be possible, but I just don't know how it works on here. So
As a vision person, I feel like I'm biased, and so I would say it's probably easier to fool it with sound. But honestly, I feel like it depends on the robustness of the model and like the breadth and depth of the
yeah.
training data, as opposed to like one domain is easier than the other.
yeah,
Mhm.
because with visual stuff, a lot of things look like a lot of other things. Like it's very easy to confuse, like we saw a cup with a parking meter because
Right.
of the similarity of, a line is a line, a rectangle is a rectangle. But if you have a sound which has a distinct frequency and amplitude, uh, it might be like, if that's how it does it, if it uses frequency and amplitude, or maybe it does something else, it might be harder to fool that because of the nature of sound identification. So maybe, again, I also have no idea, but that sounds really cool.
Agreed.
Oh, here it is. I just found this thing on their website. Let me share. So yeah, it's basically all about like this one's just recognizing noise or like keywords, right? But there's this whole thing about recognizing sound or audio, right, based on like input words. I'm not sure if this works on the Raspberry Pi itself,
Mhm.
but this is something you definitely look into if you're interested in that kind of thing. Everything, honestly, everything is on the website. You just gotta explore it and learn more about it.
Rich asks, have you tried any motion planning algorithms to use the camera as sensor input to navigate the robot?
Not yet. The main reason that I haven't is because I don't have a good. I've tried. So right now I can figure out like the left side and the right side, but depth is really the main issue I'm battling with right now. So there's one option of using two cameras, right, to figure out at like different angles, and then using like trigonometry and stuff like that to figure out the depth. But the option I'm opting for, it's a little less expensive, but also a little easier to implement, is just using a sonar or not, yeah, sonar to just figure out what the distance is from the object. Obviously, it's not going to be that simple because there's going to be interference and stuff like that. But I think definitely down the line, when I learn more, right, about that kind of stuff, I'm definitely going to try it. Because like I said, the whole purpose of getting into this project was for me to learn a lot about this stuff. And I've definitely learned a lot. So yeah.
He then followed it up with, or use an RGBD camera for $15,000. LOL.
Yeah, I saw that. Yeah, I was like, I was looking up online on different methods of figuring out distance, and I saw like you could spend $15,000. You can spend
Right.
$15,000 on this camera. I'm like, no, okay, I don't have that kind of money.
So luckily, this is also a problem that people have not like solved sufficiently, because it's not accurate by any means exactly. But there are monocular depth estimation systems, which is just doing the depth estimation with the images from one camera as opposed to two, like you were talking about.
Okay.
But the ones that I know about are in PyTorch, which is like TensorFlow, but just made by, I think, Facebook instead of by Google. Because the tech companies got
I
it,
mean,
I guess.
I'd definitely be interested because I've been trying to look in because I think for now I had a sonar sensor lying around, right? So that's like the other reason I decided to take up this project was because I had a lot of spare stuff lying around. And so I'm like, okay, I'm actually going to use this for something. But yeah, I'd definitely be interested to learn more about what you were just talking about. forgot
Or
what it's
even
called.
just don't have it navigate based on what it sees. Just tell it where to go based on this tutorial.
Yeah. Oh
Great.
yeah. So like there,
Yeah.
yeah, certain signs. Yeah, that could work.
Just tell it, hey, you're gonna bump into something, go left. And it'll go, oh, I recognize the word left.
Yeah, definitely. Wait, actually, one other thing.
Mhm.
It's completely unrelated.
And he's gone.
So as a part of this, right, I figured, let me stop share so I can actually see it. Right, so as a part of this, I actually began like, what's it called? So I like designed my own PCB, right? And so
Mhm.
that's just like part of the project that I tried to do. And it's like, it's pretty cool. So like I said, a lot of the project has definitely taught me a lot. So yeah, that's pretty much it.
What does PCB stand for? I think there's one
Printed
question I've
circuit
never
board.
had answered.
Printed, as far as I know, it's printed circuit.
Printed circuit board. Okay.
Yeah.
That's crazy. I know what it was, but I never questioned. I wonder what this means. Blindly
Yeah.
accepted it. But thanks so much, Ahmed. Are there any more questions from anyone else?
Yeah, thanks everyone. I really appreciate taking the time out of your day.
Oh, thanks. This was really interesting.
Agreed.
Yeah.
This was fun.